Hello everyone. This week on Garage Time, we're going to try to do some Autobody lead work on this old Porsche 911 Outlaw project. Stay tuned.
Garage Time.
All right, so I've had a chance to clean up this corner, and it's not as bad as I thought. I just need to bridge that gap there, this gap right here. If I can get rid of that gap, then I'm okay to just lead over it and kind of create the shape again. This side's a little bit better. At least the gap's a little bit tighter. So from the top view, you can see this does curve in slightly right here, but I'm just going to weld this up and then fill it with lead. All right, now what I've done is I've welded up that big seam with the MIG welder, and there's just this really thin sheet metal. It's hard to do with the MIG welder. It's like 90% done. There's a couple small pinholes. Rather than trying to just glob on more metal with the MIG welder, I'm going to go back with the TIG welder and fill it up. There's also some porosity in the factory welds that was underneath the lead, so I'm going to try to take care of that, clean that up a little bit so that the new lead will have something to stick to. I have a few of these holes that are left over from the spot weld cutter. So over here, especially, I have a few holes underneath this tape. There's one, and then there's a second one right here. And so this tape is holding in a very small patch. So normally I try to drill the hole out and make the patch a little bit bigger, but I'm going to try to weld this in. This is probably a 5/16 diameter hole. So this might be the world's smallest patch, but you can see there's a tack right here, right where my wire's pointing. Small tack, that holds it in position. Now I just have to weld all the way around, and this will be done. Move on to the left one. Okay, here's a shot of all those holes welded up. So now the goal is to use some lead to remold or reshape this area here. Just give it some smooth contours and blend it in with the existing lead. Same thing on this side. Here's the lead back here. Here's the bare metal, some factory welds. I'm trying to get the metal as clean as possible with some acetone, and I'm just hitting the metal, even the lead, real lightly with my, I have this carbide grinder. So I'm hitting it really lightly. Not trying to throw a bunch of lead in the air, but I am trying to get shiny metal in both the existing lead and the original steel. So that's, it's got to be super clean for any lead to stick. Okay, now you're looking at the area as clean as I can get it. I've scratched all the surfaces, I've cleaned it with acetone, I've wire brushed it, done everything but sandblast it. And I like using lead in this area because, you know, this is kind of a high stress area where these corners come together. We could just fill this with plastic filler, but there's a high chance that it could crack here in the future, and it's going to be a little bit thick right here. This is going in, and we want it to come kind of around. So we're talking about a 1/4 inch, maybe thick of lead right here. This is really difficult because it's a small area and it's vertical. It's going straight down. So the lead is just going to want to just drip down. right, I'm having a little bit of trouble getting this surface to be all the way tinned. So you can see right here, there's a pocket where the lead is just not sticking. So this needs to be kind of cleaned out a little bit more. This surface over here is looking mostly tinned. This surface here is looking pretty well tinned, and then underneath here there's a little bit of a gap here that is not taking the lead very well. So I just need to clean this a little bit more. I couldn't find the flux that I normally use. So normally I use a flux that has some tin in it, but this time I'm just using some hardware store 50/50 lead just to get the tinning started, and then I have some higher lead content in this bar down here below. But this is really important that this is absolutely clean, and soldering around these factory weld joints is difficult because the welding is kind of porous right here, and there's just lots of places for contaminants to get trapped. This time I have a carbide burr on my Dremel bit. This one is very sharp, so I can get inside the nooks and crannies of this little tiny weld. Okay, here's what the tinned surface looks like. It is kind of hard to see on camera, but there's lead everywhere. There's some flux residue in the black spots, which looks ugly on camera, but most of that wipes off. Some of it's just in the nooks and crannies. A little flux isn't going to hurt as we continue. It's just going to rise to the top, and we just kind of leave it there. Okay guys, here it is with the lead in place. Lead never looks pretty, especially on camera. Try to zoom out a little bit. So what you're seeing is some of the wax from the wooden paddle, and you're seeing some of the flux rise to the top. So it looks like just a mess, and it looks like the lead is not smooth and it's kind of tacky, which it is. And I'm not saying this is the best lead job ever. I'm pretty certain the adhesion is okay. I think it was hot enough to make a good metallic bond. So this won't look good until we start to file it down. But I think I got enough on there to kind of create the shape that I need and just fill up this corner. And it's pretty thick in there. At least 1/4 of an inch. I used almost half of a rod of lead, and this is what's left on the floor. This, this is me being a rookie just trying to get this stuff to stay on a vertical surface. sometimes it just melts out. Okay, real quick, I just wanted to give you another shot of these leaded areas with some natural light, because I know that some of these halogen lights kind of make it look shiny and reflective, and so this is a little bit less light, but now you can tell sort of, you know, what my eyes can see. This is just globbed on lead, patted down with the kind of wooden spoon. See some drips there on the very bottom. And then on this side, so you're seeing a little bit more light here, but this is really the same thing. So I was able to get lead all the way on that seam where the quarter panel fender reaches the chassis. So all that is leaded over, so it looks like it's all one solid piece. And I was able to blend the lead with the existing lead, and I fanned it out all the way to about here. I fanned it out all the way to about there, which is way more than I need, but I just wanted to have a smooth transition between the leaded area and the steel area. So after lunch, I'm going to come back and start filing on this. This is going to be a difficult place to shape because it's so contoured, but I think in the end it's going to be worthwhile. Okay, so now it's time to start shaping this ugly lead into the contours that we want. And it's going to be a slow process. I'm not sure how much fun it's going to be able to watch on video. And I don't really have the correct body files. I have this old round file, which I think I can get into most places. But this clogs up pretty easily. It's going to go kind of slow. And the other thing is, you know, you really don't want to use any kind of sanders on the lead, because lead is toxic, and if it becomes sanded into fine particles, then it can get ingested in your lungs, and that's the worst hazard with the lead. Okay, so this side is done. You can see that the lead is shaped, the best I can. So we have this nice curvature. So looking at it from the top, it comes like this, and then comes around like that. So you can see, maybe without shadows, this is the curve that we wanted, coming around like that. Here's a nice blend with the existing lead. So you really can't see where the old and new starts. So that means it melted together really well. Here you can see where it feathers in with the actual steel. So the darker gray is the steel and the lighter gray is the lead. There's a couple spots here where the weld is coming through. And then down here, this is where it was a little more difficult to apply the lead. There are some pinholes. I don't know if you can see them. I don't know if you can see them there on the camera, but there are a few pinholes, and this is pretty common. It's not worth trying to fill them up with lead. It'll just drive you crazy trying to get every little hole out of there. So now that most of the structure is created here, this will be filled up with plastic filler. You can see here, this section where it blended into the steel started to get a little bit low. So I couldn't file it all the way down. I think some of the heat from this weld probably shrunk this metal a little bit. So it's a little bit depressed right there. So when the file came along, it showed that it was low, but there's nothing I can do there to add more lead. You'll be chasing it forever. So plastic filler over here. I'm pretty happy with the adhesion of the lead. I don't see any of the edges lifting, especially on the real thin areas. It blends down real nice to the steel. All right, this side is now done as well. Went a little bit better than the other side. I think there's a little bit less pinholes on this side. I probably did a better job, just with a little bit more practice, a little bit better job applying the lead. How that shape comes in. So the overlapping seam along here is totally covered up with lead. Also another reminder that, this is the motor mount right here. That's the motor mount. Here's the location where it meets. So very high stress area. Okay, here's the right side gap and fit. This is not the original hood for this car, but it does seem to fit pretty well. That's the gap along the right side. And then the gap along the left side is also pretty nice. So if I put my hand here, you can see this is a good lineup on the back here. This gap's consistent all the way down. So I'm happy with this section. Next step is to figure out what I'm going to put in this big empty space. All right, well that's it for the leading. It's not my favorite thing to do, and I am by no means a pro at this. I just wanted to give it a try. I have done it before with some mixed success. I thought this went pretty well today, but it's not my favorite thing to do. It's toxic, it's messy, it's difficult on your hands, it's hard to file. But in some cases, lead is a good choice. Like I showed you a few seconds ago, the motor mount is right next to that joint, and it is a potential for cracking. I don't know if it's common, and I just want it to look finished. I don't want this to look like a kit car with parts just thrown on. I want it to look like it did in 1973 with maybe a couple custom touches like the fiberglass bumper. Porsche did use fiberglass bumpers too in their ST and I think RSR builds. So this is very much like the factory would have done it. So I think it's a good solution. Let me show you some of the materials that I used, and I couldn't find the good stuff. I've used it in the past. I have some flux that has the solder built in. So as you're cleaning and fluxing, it puts a layer down of tin. So this stuff I found today was just from Home Depot. But I will put a link in the description below of what the best soldering flux is, and then I'll show you here what I used, which certainly works. I think it maybe took a little bit more time, but it was better than waiting days for new flux to arrive. Okay, so starting with the flux, this is what I used. I'm pretty sure this came from Home Depot. I can look it up too, but this is just basic soldering paste flux. It cleans as it fluxes. And one thing that's really, really important is this brush. It looks horrible. It's made of copper, and inside it has a extendable brush. The bristles are the whole length of this thing, and as it's consumed or melted away, those bristles can be extended out. And I'm not sure what the material of the bristles are, but it's meant for acid and it's meant for tinning. So this one is, I think, really important. So as you could see during the video, I wasn't talking a whole lot because I was trying to concentrate, but the brushes, you need to make sure that as you're fluxing and getting the tinning down, you need to make sure that the tinning is wetting all the surfaces. And that means that the solder is sticking everywhere, it's flowing, it's kind of dripping off. That's really important, and this brush allows you to check that. So as you're moving the brush around, you're looking for spots that become bare as you brush over them. If they become bare, then that's a sign that there's a reaction to the lead and the two are repelling each other. So I really like this brush. I think it's one of the most important parts of the job. The tin, just like paint prep, the tin is the most important step for lead. If the first layer doesn't stick, nothing on top of that layer is going to stick either. Then this is a soapstone, nothing to do with lead. The next thing was, so this is the solder that I used, and this is nothing special either, other than there's no flux inside the wire. It's just solid solder, and I don't know if you can see there, it's 50-50. So that means 50% tin, 50% lead. Now, the more tin it has, the more fluid it becomes, the more it slides on the surface, the easier it is for it to get inside the nooks and crannies. So this was a good one to start with. The actual lead that I used was 30% tin, 70% lead. And the 70% is beneficial, especially on vertical surfaces when the material just wants to run off due to gravity. So the 70% lead is there to behave more plastic-like. So it doesn't want to run off. It's kind of a plastic behavior. Has a little bit longer melting window, so you have time to work it in place. And this is the tool that I was using to sort of push the lead into place. I would apply the lead where it needed to be, and then this tool this is a piece of hardwood. I think it's maple, but it's just screwed onto a piece of stainless strap. And this is what allows me to just push the lead where it needs to go. I apply it where I want it, and then if gravity's acting on it, I can just push the lead where it needs to be. There is a little bit of wax on this surface, so it tends to burn because of the heat. And the wax helps it slide along the lead and also prevents it from burning. So this, I think, is paraffin wax or beeswax. I think it's paraffin wax. I can try to look that up. It's been several years since I've even tried this leading process. But when I heat this up a little bit, it becomes liquid, dump it in there, and this treats the wood to protect the wood and also make it slide a little bit better along the lead. I didn't use this for this episode, but this is just another wood block that has a little bit of wax on it. And I've used this on bigger projects where I can just push and manipulate the lead, kind of like it's almost like a stamp. But this allows me to manipulate the position of the lead. In this project, this high curvature was really what was important for the little tight spot that I was working in. And then the file that I used is just this. This is about, it's a tapered file. It's round. It's a pretty fine file. And this is probably, I don't know, 3/8 of an inch in diameter at the biggest point. And that's really all I used to get the bulk of that part shaped. I did use this carbide burr only if I needed to. I don't like using power tools on lead, but this is a pretty aggressive cut, so it really takes big chunks off. So in places where I had to get into tight areas and this tip here was too blunt, I would use this pointy end to really blend it in, especially on the left-hand side where it had a little extra boss on that. So that's it. All right, guys, I need to end it here this week. It's a little shorter this week, mostly because I am waiting for that license panel plate. I purchased 2 of them. They're both used and they were cheap. I think one was $50, the other was like $85, and that's shipped. So they haven't arrived yet. That's probably the next step in getting that rear end sort of fit. I think I'm going to go with that steel license panel and make it look original there, and then try to blend in those fiberglass bumpers on the side. So that'll be later. Before I can do too much blending, I'm going to start to tackle these fender flares. So thank you again for watching, and if you're enjoying my progress on this Porsche 911 Outlaw project, I really appreciate that. Please like the video, leave a comment down below, and subscribe if you haven't already done so. I would also like to thank Hagerty Insurance for an article that they featured on their website in the restoration section. I'll leave a link to that below. It just was a shout out to the work that I'm doing, and shared it with a little bit of their audience, and it's been going really well. I think it's helping the channel grow, so I appreciate that. Thank you again, and we will see you next week.